Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily lead code problem, and the problem's name is get equal substrings with budget. So you will be given two strings S and T, which will be of same length, and there will be an integer which will also be given to you, which represents maximum cost. So you want your S to look as much as like as T. Okay, so you want to has to change to T basically. Okay, and changing the ith character of S to the ith character of T cost you absolute value of their difference. Okay, I that is the absolute difference between the ASCII values of those two characters. Okay, at the ith index of S and T respectively. So what you have to return is you have to return the maximum length of a substring of S that can be changed as same as corresponding substring of T with the cost less than or equal to maximum cost. So you cannot, you know, use operations which will cost you more than the max cost constraint that is been given to you, and your target is to get the maximum portion of S equal to the maximum corresponding portion of T, and you have to return the length of that longest portion that we which you can make equal to which you can make equal, you can say, in both of the strings. Okay, so it is something like this. If we, you know, try to imagine it, let's say this is S, this red line is representing S. Okay, and let's say this blue line is representing T. So you want a substring in both of these which after some operations, provided those operations are not exceeding the maximum cost constraint, you want this portion to be as large as possible. Okay, and then you will be returning the length of this portion. Okay, so this portion is nothing but substring of S. So you have to return the length of the largest or maximum length substring of S that can be same as the corresponding substring of T. Okay, so you have to return its length. So before thinking of an approach, let's quickly have a look at the constraints. So according to the constraints, or the input size constraints, you can say the length of S will be of order 10 raised to power 5, and it will be equal to length of T. Okay, and the maximum cost which you can use up to make some operations to, make two characters of S and T equal will be of order 10 raised to power 6, and it is mentioned that S and T will only consist of lowercase English letters. Okay, so these are the constraints. Let's quickly think of an approach. So basically, the very first approach that is coming to my mind is, as you can see from the this diagram also, this is a window like structure. I mean, if let's say starting from this point, this is the start point of the window, let's say window start point, and this is the current end point of window, and then let's say the current code, the cost that this window making characters equal in this window will be used. So let's say the current cost is the cost that will you know that will be there if we want all the characters in this window to be equal. Let's say the characters are something like this. Okay, now let's say this is same and these two are not same. So you will use some cost to make these two pairs equal. Okay, so let's say it is equal to the current cost. Okay, and then in the input you will also be given your max cost. Okay, so if your current cost is less than the max cost, then it is very well. You can keep expanding this window. For the expansion part, you will move the endpoint towards the right. Okay, so this window size will increase towards right. Okay, and let's say at a certain point, or even at this point, your current cost is exceeding the maximum allowed cost. Okay, so it is greater than the maximum cost, max cost. So then you have to decrease your window size. You have to squeeze a little so that the extra cost is reduced, and you are well within the bounds or constraints of the maximum cost. Okay, so how you will reduce or squeeze the window size? So in this direction, expansion will be there, expansion of window with endpoint of current window. Okay, and if you have to squeeze the window a little bit, then what you will do, in case of expansion, this start point was fixed in case of expansion, but in case of compression or squeezing the window size or decreasing the window size, your end point will be fixed. Okay, so you will keep it as it is. Let's say this was your end point, and then you will squeeze your window by moving this start point. Okay, now let's say the start point came here from this position. So as you can see, the overall width of the window is now reduced. Okay, which is smaller than the earlier window size. This was window size earlier. Now you will also see that with this little compression or squeezing the window size or making it less than previous value, you will also lose some characters. Okay, so all the characters that were in this portion will be gone if we take another color. So this portion characters in this portion will be gone. So you should be decreasing the current cost by the differences of absolute value of difference between the characters of S and T in this portion. Okay, so your current cost will reduce a little bit, and as when it is well within the bounds of maximum cost, so when this condition satisfies, current cost is less than equal to maximum cost. So at that point you will stop decreasing the size of the current window, and this will be your current window size. Okay, and if this condition is satisfied, then you will have another variable which you will be returning as the uh, you know return value of this function that is to be completed by you, of returning the maximum substring size. So you will have another variable max length. It will be initially initialized to 0. Then you will keep updating this maximum length when this condition is satisfied. Current cost is less than the maximum, less than or equal to maximum cost. So then your max length will be updated to maximum of max length and current window size. Okay, and this is how you will be approaching this problem. Now let's have a quick look at the implementation. Okay, For discussing the implementation, I will be taking the implementation to the board. The code is not that large, so we can definitely discuss it on the board itself. So this is the code. So what we will be doing is, we will be using a two pointer kind of approach. Okay. So those two pointers are nothing but the start point and the end point. So these are these pointers, start point and end point of the window. Okay, and this technique of squeezing the window, expanding the window, and sliding it over the inputs or the things that you are traversing is called sliding window technique. Okay, those of you who are not familiar with it, you know this technique, or uh, you know are not still not able to, still want to have something to go in the depths of this technique and when to apply it and how to apply it. Although it is very, the explanation that I just gave you is very easy to follow through, and it should be sufficient enough for you to understand this sliding window technique. But if you still want to have something to read upon it, then I will provide an link to an article which will be explaining this technique. Okay, you can, if you are interested, explore that article. Okay, so now coming back to the implementation. In the implementation, what we are doing is, this left pointer is nothing but the start point of your window. Start point of window. Okay, and this right pointer is nothing but the end point of the current window. Then there is one variable which is holding the value of size. Okay, since it will be required to traverse or move this window. So this will be your current cost. The cost current window is using to make both strings equal, or at least the current window size. And maximum length is the maximum length window size which is equal in both of the strings. Initially we have set its value to 0. So till when we will be moving this window from left to right direction, uh, till this end point do not reaches to the very end of both of the strings. So till your right pointer or the end point is less than the size, you will keep moving your window. First of all, you will see what is the current cost by adding the absolute difference between the current characters. So for the current characters that you are visiting, you will be taking the value of the characters present at the end point, or you can say right pointer. Okay, then if the current cost is greater than the maximum cost, it means you have to reduce your window size. Okay, so here your window size should be reduced. Okay, so in order to reduce the window size, what you will be doing is, you will be fixing your right pointer or end point. Okay, and then you will be moving your left pointer or start point towards the right pointer. Okay, so this window size will be shrinked. So this point is fixed, then this point will keep on shifting towards this point. This is the right pointer and this is the left pointer moving towards the right pointer. So this is what is happening, and along the way you will keep decreasing your current cost by the absolute difference between the characters pointed by the left pointer or the start point of the window. Okay, and then you will keep moving your start point or left pointer towards the right pointer. And if it is the case that there is still one character, okay, so in the window which is represented by this condition, then you will track the maximum length and updates its value. The length of the current window will be nothing but start end point minus start point plus 1. Okay, so you are considering start point and end point also in the window size, so that's why plus 1. Okay, so right pointer, which is the end point, minus the start point, which is the left pointer, plus 1. Okay, and then you will keep incrementing your right pointer, moving your window towards the very end of the strings. At last you will be returning the maximum length. So you must have guessed the time complexity and space complexity. Anyhow, I will also tell you, just for you can be sure that your evaluation was correct. So yeah, time complexity wise, you have seen that it is nothing but order of size, since you are doing just a linear traversal here. Okay, and space complexity wise, it is nothing but order of 1. You are using constant extra space here. You are not using any space, basically just playing with the pointers. Okay, and yeah, that is how you will be solving this particular problem. If you are still having any doubts or any queries in general, then you may ask them in the comment section. I hope this solution walkthrough added some value to your journey of owning your DSA skills. Till then, keep practicing, keep solving problems, and I will see you in the next video. Thank you for watching.